And like a classic integrate to get the total, you need to find the maximum number of people in the park. So at the beginning of the day, E of t is bigger than L of t, and later in the day, L of t is bigger than E of t. You know, at 5 o'clock, there's more people leaving than entering at that point. So we need to figure out what time of day they're equal. You know, when it changes from entering, when it changes from entering is bigger than leaving, and then all of a sudden leaving is bigger than entering, and that's going to be the moment. So for D, we're going to set E of t equal to L of t. And luckily on our calculator, we can graph that because I've got it right here. It's the only one that's highlighted. So we're looking for the 0 of that. Hopefully it's nice and beautiful. We're not going to get a weird fraction anymore. I'm so glad this is the fastest, you know. Okay, so there it is. So let's find out what number that is. We're going to find the 0. Oh, it's still graphing. Hello. So, oh, well, too bad I was going to tell you a joke, but here we go. Let's find the 0 of this, and the left bound is that. You can see the y value is positive. I just need to make sure there's a sign change in the y value. Positive. And we need it to be positive, and then we're going to look for it to be negative, and the y value is negative now. So we definitely have the 0 in between those two. And I guess you just press enter again, and you get 15.7948. So what is that? 3. At what time? So at time equals 15.7948, the number of people in the park is a maximum. And maybe justification if we want 15.7948, and we'll call this E of t minus L of t. And so this is the rate they're entering, right? And it goes from positive to negative, which means it's a maximum. So that's justification too. So anyway, that's what we got. All right. Okay, so let's go over the scoring guidelines. First part, we had to find how many people entered by 5 p.m. and at 6,000 entered by 5 p.m. 1 point for the limit. So if you go from 9 to 17, that's a point. 1 point for the integrand, you just need E of t in there, and 1 point for the answer, right? And we had all of that. And then find out how much money they took in. Looks like it's perfect, right? 15 times from 9 to 17, 11 from 17 to 23, and it's $104,048. The amount collected was, and they didn't say the time interval. I think the units is there, but not the time interval. So I would expect to see the time interval when you sum it up. Okay, so anyway, C, we needed to find the meaning of H of 17 and find H prime of 17 and the meaning. And H of 17 is, right here, the number of people in the park. No. H of 17, where is that? Oh, there were 3725 people in the park at time equals 17. That's H of 17. Meaning of H of 17, so there's the point right there. And H prime of 17 is negative 38.281, and that's what we had. negative 38.281. And the meaning is the number of people in the park was decreasing at a rate of approximately at 5 p.m. at time equals 17. So I said at 5 p.m., but it's the same time. And they did round to the nearest person, but this does not say round to the nearest person. I don't think we lose because we didn't, because it doesn't say that we need to. It was confusing. Anyway, D asks for the maximum when it happens, and you just have to set, well, E of t minus L of t equals 0, and I set those equal, which is the same equation, and get the answer. And at time equals 15.794 or 15.795, rounded correctly to the nearest thousandth. But that's why I always use the 10,000th, because you can round wrong earlier. Anyway, looks like we got all the points. So there we go.